order of magnitude is used to compare measures and to estimate and perform rough calculations. The order of magnitude of a quantity is the number rounded to the nearest power of 10. For example, the power of 10 closest to 95, this is 100,000, this is million, 95 billion is 10 to the 11th power. Okay. So what we need to do when we round to the nearest power of 10, and we're looking at this number here, 95 billion, is it closer to 10 billion? Or is it closer to 100 billion? Right? Because both of those are powers of 10. 10 billion and 100 billion. And it's quite obvious that 95 billion is closer to 100 billion. So what does that mean? That means I have 100 followed by 9 zeros. And if we're writing this as a power of 10, we count the zeros. Right? So we say 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so that's how we get 10 to the 11. And that's how we round a number to its nearest power of 10. Let's go ahead and take a look here in astronomy. The order of magnitude of the mass of Earth is about 10 to the 27. The order of magnitude of the Milky Way galaxy is about 10 to the 44. How many orders of magnitude as big as the Milky Way galaxy as Earth? So what we need to do in order to solve this problem is we are going to take the order of magnitude of the Milky Way galaxy, and we're going to divide it by the order of magnitude of the mass of the Earth, because it's asking how many orders of magnitude as big is the Milky Way galaxy as the Earth. So that's going to be 10 to the power of 44 divided by 10 to the power of 27. Okay. The order of magnitude of the Milky Way galaxy divided by the order of magnitude of the Earth. So from here, we can apply the quotient of powers property to solve this. So we have the same base. The base here is 10 in the numerator. The base is 10 in the denominator. So we keep the base, and we take 44, and we subtract 27 from it. The power of the numerator subtracted by the power of the denominator. And that's going to equal 10 to the power of 17. 10 to the power of 17. And so how many orders of magnitude as big as the Milky Way galaxy as Earth? It's 10 to the power of 17. And I'm going to put a box around that. Let's go ahead and look at number 18. The gross domestic product for the United States in 2008 was 14.204 trillion. And the GDP per person was 47,580. Use order of magnitude to approximate the population of the United States in 2008. Now, what is the GDP? That's the total amount of money earned in the United States, right, for this year, 2008. So if you add up everybody's salary across the United States, it adds up to 14 trillion. It's saying here that the GDP on average per person was 47,000. So if you add up everybody's earnings for the year and you divide it by the number of people, you would get 47,000, right? Of course, some people earn more, some people earn less, and this is average. So what the question is asking is, use this information to approximate the population of the United States in this year. Right? And so what we need to do is we need to take the GDP for everyone in the United States and divide it by the GDP per person. Right? This is how much everybody earned. This is how much one person earned. So if we take how much everybody earned and divide it by how much one person earned, then we will be able to say how many people were in the United States at that time. So this problem is very similar to the Milky Way problem. However, we need to start by rounding to the nearest power of 10 here and also here. Okay. So is this number 14 trillion closer to 10 trillion or closer to 100 trillion? All right. Well, obviously this number here is closer to 10 trillion. So we're going to round the GDP for the United States to 10 trillion. And then we're going to round the GDP per person to, now here again, is it closer to 10 trillion? I'm sorry, 10,000? Or is it closer to 100,000? And so, of course, it's closer to 10,000. And here is 10 trillion. Right, this one here is close, but it is closer to 10,000. So we're going to round to 10,000. This one here we're going to round to 10 trillion. So how do we do this? It's going to be 10 followed by 12 zeros. 2, 3, 2, 3, 1, 2, 3. This is 10 billion. And this is 10 trillion. Okay. Now how can we turn this number into a power of 10? We say 10 and we count all the zeros. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 10 to the 13 is the GDP, the order of magnitude of the GDP of the United States. And then over here, we're going to say 10,000. So to turn this into a power of 10, we say 10, and we count the zeros as well. 1, 2, 3, 4. And what we're going to do here is we're going to take the GDP for the United States and divide it by the GDP per person. So we're going to say 10 to the power of 13 divided by 10 to the power of 4. And we know from the quotient of powers property that that's going to equal to 10 to the 13 minus 4. And that is going to equal to 10 to the 9. I'm going to put a box around that.